Right, come round.
This is work.
What?
I feel like any maths we do in the department counts as work.
You don't work here anymore, and it's not my job. Right. Oh, I'm not in. What do I need to do to be in? Like that. Okay. Right. So, David, I've got
Yes.
2 sequences for you.
2.
Yeah. Well,
I'm excited.
did you look at the other one?
No.
Good. So you haven't looked at the other one.
No.
Right.
Well, I might have. Is that annoying?
I suppose that's possible. Right. So I'll put the webcam down there, and we'll do the first one.
1, 2, 5.
So this is.
Oh, you sent me this.
Yes, that's why I asked if
Okay.
you'd seen it.
So, yeah, but you didn't tell me we were reviewing it. You just said, look at this.
So let n squared be q times prime the nth prime plus r, with r between 0 and the prime, then a of n is q plus r. So a way of writing n squared plus as the nth prime times something plus remainder.
Mm-hmm. And you add them up for some reason.
Yeah. So that's not why I found it.
Okay.
I can't even remember why I found it, but I have a feeling the first comment might be what we want. The digital sum base the nth prime of n squared.
Okay.
So I'll try and write. So like if we have 2, then 2 squared is 4. And in base 2, that's 1. Hang on. What is it? 1, 0, 0.
Yeah.
So.
Oh, not maybe that's 9.
I know. Well, I mean, I was just writing like that. It's hard to do with the funny pen thing. So
let me try.
Q here is what is it? It's like
I don't know what we're doing.
I don't know either.
What term are you trying to work?
We're trying to write for n is 2.
Okay, so we have to write 4, and the second prime.
Yeah, second prime
is 3.
Digital sum base. So digital sum base 3 of 2 squared. Okay.
So 4 is equal to
Out.
3 times 1 plus 1.
Yeah. Why is that not? Oh, that's rubbish. Right, there we go. So 4 is equal to 3 times 1 plus
1.
Alright, 1 times 3.
Yeah. Oh, I don't know which way around.
Yeah. So a of 2 is
1 plus 1.
2. Okay.
Should we try 5?
But if we write 4 in base 3, 4 in base 3 is 1, 1.
Yeah.
Yeah, so that's what I was doing.
Okay.
So then if I look at, if we take as 3 and 9 in base 5, it's 1, 4.
Right.
So little sum of that is 5. Because 9 is 1 times 5 plus 4. So is it obvious in fact?
What's obvious?
Is n squared always going to be, is that always going to be a 1, that first bit?
No, I don't think so for large
it won't.
numbers.
Okay, so how do I, there we go. So let's pick, what's a good prime that you know exactly which prime it is?
The 21st prime is 73.
Why do you know that?
It was mentioned in the Big Bang Theory. So the 21st prime is 73. 7 times 3 is 21. 21 backwards is 12. The 12th prime is 37, which is 73 backwards.
That's a good fact. I do like that. Right, so n is 21. So 21 squared is
441.
441. I was going to get there. All right.
I like that square. Because it's 12 squared backwards.
And P of 20, so the 21st prime is 73. So it's going to be
6
5.
of them?
Oh, 6 of them. 6 times 73 is 438.
Mm-hmm.
Yeah, so 441 is 438 plus 3, which is 6 times 73 plus 3. So A of 21 is 9, we reckon.
Can we check?
No. I'm going to go through all this because it's easier. Did we get 9?
Yeah.
Yeah, cool. So
Can we look at 12 since we know that as well? Just 12 is really high. I want to know what's going on.
12 is really high.
That's higher than 9.
So 12th prime is 37.
Yeah.
So 144 is not 4 times that, it's 3 times that. 3 times 37 plus 111 plus 33.
So that's why it's really high.
Yeah, so A12 is 36.
Mm-hmm.
Yeah, okay.
It's interesting how when it's small as well.
Yeah, is that where I came up with this? You can say.
I bet any number can only appear a finite number of times. Or is that just nonsense?
I don't think you've got any basis to say that.
What if we think about...
So, a prime number plus 1 being a square, how often does that happen?
Oh,
Because that would be 1 plus 1.
I have no idea.
Give a value of 2. So I wonder...
No, because a prime number plus 1 being a square,
It would have to be n
n equal to
squared.
n squared minus 1,
Ah.
which factors as n minus 1 and plus 1.
But, can we look for places where this is 2?
It's only going to be the beginning,
It's only 2 at
because
the
it
start.
always factorises n minus 1 times n plus 1.
Oh, of course, right. So,
Mhm.
what else might appear lots of times? 9 looks like it comes up a fair bit.
That's interesting. I can see it twice.
48.
There's a couple of 16s.
Is there like a... There should be a thing on this that shows you frequencies.
I can see 3 16s.
Okay, no, 16.
There's 2 there
Yeah.
and 1 there, which is really useful for all of you.
Well, I think the mocam might be on, so you'll see your finger going.
Ah, right.
You can say. I don't know how it's working. Yeah. So, right. Then there's a whole load of other stuff, which I think is just rewriting the definition.
Mm-hmm.
No references to anything.
That's a shame.
How do you feel about the name Werner D. Sand?
Why? What? Oh, it's quite a good name.
Werner Sand. Yeah.
I wonder what the D stands for. Come and click on them.
Okay, I think it'll just come up with his wiki page. Retired chief librarian. Hey, interested in number theory, mainly prime numbers. So
Number theory.
he naturally found the OEIS, and that's all number theory is. Interesting.
I've never heard of him.
I don't know how we would find the rest of his sequences.
There's a few names I do recognise all the time.
Yeah.
Like Charles Greathouse the 6th.
Yeah.
He's just...
A long line of great houses and some lesser houses before that.
Did I tell you, I showed you a picture, didn't I? And I finally got to hold a copy of the original OEIS, well, the EIS.
The Handbook of Integer Sequences,
Yeah.
wasn't it called? Yeah.
Yeah, my ex-boss had one. So it was a fantastic bookshelf.
I think Sloan gives out a copy each year for the best sequence.
Right, well,
There's some
we've got
motivation.
to come up with a sequence by the end of this.
I think we need to find a really good value of this sequence and make a sequence of the ends that have that value.
I don't think one can appear with infinity often.
What about record setting values? So it would go 1, 2, 3, 6, 7, 11.
I can't see 3 anywhere.
No.
Could it never be 3?
So 2 times the prime plus 1. I think this needs way more terms. Has it got? Where are the keywords? Non-negative. It hasn't got more written on it. I want to plot like a million of those. Okay, we'll do that later.
Mm-hmm. But this is the parry code then. Parry's fast.
Okay. I think we can beat however many that is. 64 terms.
Well, we just need some primes, don't we?
Yeah, we just need tons. If only someone had written a website that listed all that. Right, I think we should review this sequence.
Okay.
Okay, so...
At first I thought it was terrible, but actually doing this stuff was fun.
Yeah.
And
Right.
so many questions.
So,
New series. Style.
yeah, A07... What's it called? A075771.
It's a new series, or like a spin-off. Christmas special.
This is... Well, we've always done just whatever you want, so... What categories do you want to have?
Well, because of the new Robot Wars, used to have style, control, damage, and aggression, and now it only has control, damage, and aggression. We have to have styling, so that the style category is carried on.
Oh, I thought you were going to say let's drop our aesthetics category. Because we had, what did we have? We had aesthetics.
Completeness, which is weird.
Well, I like that because
But we argued over what I meant every week.
Exactly. Aesthetics, completeness.
Do we have 4 categories?
Yeah, explicability. Oh god, I wish I had a better tablet. There we are. Hey.
What was the
novelty. So novelty's down here.
Really high on novelty.
Okay.
It's just silly and weird.
I've drawn 2 arrows. Let's write 3 up 3 there. Okay, what's 3 up 3? Is
I
up,
don't even know how it
titration?
works.
Up is exponentiation, isn't it?
I can't remember how it works. Would that be like 3 up 3 up 3?
3. I think it's that.
Okay.
Out of 3 up 3 minus 5. Right.
Why is this about what's going on?
I don't know. I forgot what our scores are out of.
5.
Out of 5. Okay. I can't make that go. I want it to go away. Oh, I'm so sad.
What?
Why would it not erase?
Oops.
Right. Okay. Don't make mistakes. Okay. Anyway. Yes. Aesthetics. That pin plot was pretty nice.
And I want more terms. Although that's a different category.
That's very much the other category there. I didn't like the definition. It hides the coolness.
Mm-hmm.
I think there's a nicer way of putting it, maybe in words. But that's not the
Would
style.
that be explicability?
Ah, it would. Well, okay, let's give 1 score for all of these.
Okay.
No, okay. Well, completeness is 0.
Yeah.
0.64 out of completeness.
Okay.
Explicability. I don't know. You can explain it, but you didn't do a good job.
No.
Get half marks.
I think we should give it a 3 over 2. But one of them is what we've contributed.
3 over... I thought these were things out of 5.
Why could you just give it a half then?
Well,
Okay, give it 1.
cancelled.
But we have to like take part of that. By explaining it.
Right, out of 5, what are we giving it? 3.
3.
Yeah.
Only taking 2.
Yeah, minus tax is 1 out of 5.
Oh.
Right. Aesthetics. Yes, no.
I really like this sequence. It's going to get a terrible review.
Oh, okay. Well, we'll give it 4 out of 5. And how are we combining them this year?
We just add, don't we? So what? Can we just say novelty's 5 out of 5? And then, so what have we got now? 12 out of something.
Well, I think if we take the geometric means of the numerators and the denominators, we're pretty much at 5 out of 5 because that was a huge number.
Mm-hmm.
Right, okay, so...
No, we have 12 out of 5 or something.
Total, huge number. 523 now, it's getting bigger. So, transcription error.
You only have 2 on the book.
No, I drew 3 lines
Okay.
and then it's this stupid little pen thing. So, lots.
Okay.
So we liked it.
Yes. Cool. But I do want to know 3 FRP, isn't it?
Yeah. Plus a mystery bonus point. We didn't get any small numbers again after. I mean, like 15 seemed to turn up a bit and 16 said.
49. Oh, I'm liking the squares are popping up.
What?
49, 169.
No way. 169 again. Right, okay, well, we're done with this. There's lots more to be done. We will improve it. I don't think we can improve its score. What's going to happen to its score once we've done it? The novelty will go down.
Yeah.
The completeness will go up.
Aesthetics, I'm not sure.
Anyway. The geometric mean of the scores is basically got full marks. Okay, so we'll look at the other one now.
Okay.
This one is an earlier sequence. It's
Numbers n such that n equals a sum of digits raised to consecutive powers. It's like those other numbers.
Yeah.
It's finite.
Yeah.
Can we prove it?
I wasn't that bothered about it.
Can we prove it?
Well, there's a proof right here, so you can look over there and try and prove it, and I'll just be quietly reading. Oh wait, so at some point the power you're taking it to will be so huge that it can't be equal to that.
Yeah.
Unless
We'll
it's
take
ones. Oh, it's just taking logs of both sides, isn't it? Whatever. Yields m less than 22.97. Ah, oh, there's 22.97th term. You know, there's that thing about dimensions, where if you stick a let's do some drawing on a page, why not? So if you, I don't want that, I want to draw. If you draw a circle and a square, that's a square by the way, or a square and a circle, the circle fills more of the square than the square fills of the circle.
Okay.
But in 3D, it gets a little bit worse.
Oh, yeah. I think you showed me this.
Somewhere between dimensions 8 and 9, it swaps around.
I don't know what.
Colin did a post about this, yeah.
Okay.
You know, there's a number exactly where it is. So in dimension 8 point something irrational, they're the same. So why shouldn't the same?
I've got a sequence.
Go on.
So, how many terms is there? Obviously, we can't work it out in base 10.
How many terms of what?
The sequence we're reviewing.
Oh, right. Oopsie daisy.
Because obviously, it's incomplete, isn't it?
We've got 20. Wait a minute.
It was up to 22 digits.
Ah, so that last one has 22 digits.
Does it?
No, it has 20.
So maybe people haven't checked up to.
Well, no, I would expect they've been checked up to that. It's in the Penguin Dictionary of Curious Numbers. Do I have that? I thought I had that. It must be at home. Oh, never mind.
Shame.
Right. Oh, there's some maple code. They haven't said it's been checked, but it is marked full. Yeah.
So, How many terms then?
There are 20 terms.
Okay, so A of 10 is 20 of the new sequence. So you do it in every base. So in binary, I believe only 1 would be in it, or they're counting 0.
Wait, these are these narcissistic numbers? Ah, these are the ones that in number gossip and things.
I thought you had to raise it all at the same power for narcissistic.
Ah, okay, so they're just saying it's like a narcissistic number.
Mm-hmm. So we should work out, in binary we only have 1 and 0.
Yeah.
Wait a minute, yeah. 0 could have 1 and 0. I'll be confused. Oh, in binary it's nice, because you want the number of 1s in its binary representation to be equal to its own number. Because 1 to the anything is 1. So you're just summing up the 1s.
The number of 1s in its... Sorry, the number... to be equal to the number
itself. And 1 and 0 are the only ones that are doing it.
Oh, that's right.
Yeah.
Yeah, okay.
And then in base 3 it's going to be more complicated. We'll have to do it by hand in base 3.
Where's my OneNote? Okay, so n, a of n, block 2, it's... Sorry, 2. Number of terms in the sequence.
0 and 1.
3. Do we have to do some thinking?
Yeah.
There's no easy way of finding these. Well, could we get a bound for it? How do I do that funny clippy thing? I want to take a screenshot of... how do I do it?
And this is going to win us the book.
Yeah. No, it seems pretty weird. No.
Unless it's in. I hate when you can spend hours calculating a sequence.
How do I get a keyboard? God damn it, Windows 10. Show touch keyboard button. There we are. Right. So I want screen.
It's not typing anyway.
It's called clip snipping. No.
Not just screenshot.
Yeah. Right, snipper. That's what I want. Has it started? Is that the thing that I want? Okay. New. Drag the cursor. Okay. Where is this? Would have been quicker just to write it in. Right. Paste. There we are.
Can't move it.
Damn it! I really. Right. Give up. Okay. So 10 to the m. Minus 1 less than equal to n. N is less than equal to 9 times 9 to the n minus 1 divided by 8, which is itself less than
It's a really good thing.
9 to the n plus 1 over 8. Oh, so that, oh no, I've got a highlight tool, haven't I? There we go. That and that are the lower and upper bounds. So take logs, so m minus 1 log 10 is less than m.
Have you got a calculator? Because Wolfram Alpha and this is going to be crazy.
Yeah.
Shall I give you desk?
It's in my pocket.
It's always with you. Oh, I forgot phones.
Oh, what, we're going to get a quadratic. So.
Oh, what?
No, how do we solve that?
This is linear, isn't
Oh,
it?
no. Yeah. Jeez Louise. Log 10 minus log 9 is, let's say equal. Log 9 minus log 8 minus log
Plus log 10.
log 10. Okay. Calculating. 9 log 8 log 10 log 10 log 9.
That is really nice.
I'm pressing the wrong log button. I started pressing LN and I pressed log 10. Alright. 9 log 8 log 10 log plus 10 log 9 log minus divide 22.97. Right, so that works.
Okay.
And instead of 10 and 9, I want 3 and 2 now. So 2. Oh, except we're going to get a log 1 there. How weird.
And log of 1 is 0.
Yeah. And did I do that right? 2 log 3 log plus 3
Why do I
log
feel like we're
2
going to get minus
log
1?
minus divide 4.
Probably not.
So we need to consider base 3 numbers up to 4 digits. That's too many. What's 3 to the power of 4? 81. Oh no, but then it'll be 3 to the 5 minus 1 is the biggest number we can get. So it's like 243. I don't want to do that.
No.
Okay, but we know.
But we could do, my computer could do it later.
We could. So there's another job to do. David, man, live a healthy lifestyle. Right, let's review it.
7's across the board.
A0. Oh, my handwriting's getting worse. What's it called? 032799.
Just claim I'm writing.
Just claim you're right. Yeah. Okay. So David has now taken the pen.
I'm terrible at this.
Terrible. Right. So A.
Alan? Oh, it's what you see. It's a big complex.
Okay. Right. What do you want to do first? Completeness?
Full marks.
20
Out
out of 20. Yeah. Explicability? I've forgotten what the sequence is.
Erase powers.
Oh yeah. You raise each digit to the consecutive power. Yeah. Full marks. I would take maybe 1 off because it says raised to consecutive powers, and I don't know whether.
What if you do it backwards?
The numbers backwards. If A, B, C, D.
No, because the
A, B, C, D,
number.
A.
No, because it's a completely different number.
What?
Only if it was a palindrome would that be true.
The sum of its digits raised to the consecutive powers. So 135 is 1 to the 1 plus 3 to the 2 plus 5 to the 3. 531, if you were going backwards, would be 5 to the 3 plus 3 to the 2 plus 1 to the 4.
No.
What? What do you mean backwards then?
No, I mean like go in reverse order.
Yeah.
But why would it equal? It would.
Oh, it has to be equal to itself. Sorry.
Yeah.
Yes. That's the bit I was missing. Okay, so clearly that didn't go into my head, so I'm taking a mark off.
Okay.
Aesthetics.
Can I have a look at the sequence? I haven't even looked at it.
You haven't?
I just looked at the definition. There's not many 7s to it. Oh, there is a few.
We do like 7s. It stays fairly reasonable for quite a while.
8 and 9s.
It seems. What's it doing with the number of digits? They're not. It's just that last one is so much bigger. They seem to be moderately evenly spaced. If we look at the graph, it's going to show us some stupid. Yeah, look at that.
We can take the log plot. Even the log.
Even the log plot's stupid. Right, I don't like that. 2 out of 5? 2 out of 5.
Novelty, it loses points because narcissistic numbers.
It's been and done. Yeah. What are they called? Like wannabe numbers. If you wanna be my number, go get with my digits. Taking paths forever. No. Right. How do we add that? It's 12. It's 12.
Right. We just add them.
Yeah. 12.
Which is what the other one should have been if we didn't go mad. Why is that a 20?
Is that not how we do it?
Oh, I don't know. I thought we always got a number out of 5. I don't care.
I'll go 6 out of 10. That's my last offer. No.
3 out of 5.
We'll go 3 out of 5. That's my last offer.
Should we multiply them all together?
I'll go 1.5 out of 2.5. There we go.
No!
3 out of 5. Yeah, that's okay.
It's alright.
It's alright.
It's not weird for it.
No. Beef frick.
Beef frick.
Yeah, good. Should I put something called in there? Yeah. Okay. Cool. There you go. Any sequences you want to show me?
I don't think so. I can't remember any of the numbers. I want to check my bookmarks.
Okay.
Does that bookmark into sequences, I think? Oh, awesome. I can't find any. Oh, there. Why did I bookmark this sequence? I have absolutely no idea.
Right, let's get it up. What do I have to do?
Oh, I do know. It's because I saw a puzzle on a train.
Like on the side as it went
So-
past you?
There's a train, I don't know what line it is or anything. It went from Hartlepool to Thirsk. And the tables where you have 4 seats around them
Yeah.
had things on them. So some of them had snakes and ladders. And one of them had, what's the number of triangles
Yeah.
in this triangle? And it had some things missing. And I couldn't be bothered to try and count them. So I just came up with a formula for the first few terms.
Mhm.
Rocked it in the OIS.
Okay.
And there's a reason why I saved it because I thought it was pretty. So it's A002717.
Yeah. It's an early one. N times n plus 2 times 2n plus 1 divided by 8. Number of triangles in triangular matchstick arrangement of side n. There's a picture. Ooh, a well-known problem. I was going to go to JSTOR. Man of absolute nonsense. This person's not got the picture. Mathematical Gazette, that's what it was. So. It's also JSTOR. Right,
There
okay.
we go.
There are clearly n squared unit triangles. Oh, I've done this problem before. Yeah. So, okay. So you, let's open the page. So, like, you have that. I'll have to go on upside down on that. Okay. So, it's easy to count the small ones, and then a bigger one, like that. Okay, so what's the formula?
N plus 2.
N plus, was it 2 or 2?
N plus 2 and then 2n plus 1
Yeah.
divided by 8. And can I show you why I really liked it?
Okay.
Can I have a go for the picture?
Oh yeah. Right. There you go.
Boom. I've got to scroll
You
down.
have to press that. There you go. And then, sorry, I'll give you a there.
So the similar problem would be counting squares. I was going to put an X there. So how many squares are here? Well, we have one big square, 4 2x2 squares,
Yeah.
and 9 little squares, which is the sum of the squares.
Yeah.
And the sum of I squared from I equals to 1 to n is n plus 1, 2n plus 1 over 6. And it's really similar to the other thing. Actually, sorry, that's better.
Yeah. So that's the sum of the first n squared, is it?
Yeah.
Yeah. And this looks... So with the triangles one, I didn't draw enough levels to get a triangle that's sort of in the middle of one of the edges. Like that.
There's no other shapes that can build themselves, is there? Like hexagons can't, can you? Or can hexagons?
No.
Do 4 hexagons make a hexagon?
4?
Or it'll make a hexagon that isn't regular, won't it?
Yeah, it'll make a weird...
Oh no.
So,
No, I don't think hexagons can build themselves.
no, what's the best way of doing this? You draw like a little line, don't you? And draw it. And then get... No, wait, what do I need to do? I need to get that going through the diagonals. Have I drawn enough lines for this? And then, like, here's a hexagon. And where would I put another one? Right there.
Yeah, there's nothing to build
You can't. You need a
themselves,
triangle. You need something that's showing.
I'll show you something else cool.
Okay.
Totally unrelated that everyone would have seen.
Yeah.
So the sum of I from I equals 1 to n equal to n plus 1 over 2. And the sum of I cubed from I equals to 1 to n is equal to n squared n plus 1 squared over 4 is equal to the sum of I equals 1 to n of I.
Whoa.
And
There's a nice animation somewhere that shows, like, it builds up the first, like, the first numbers and the first squares.
I think this is right, but if it's wrong,
So was that I to the power of 24 plus 1?
2k plus 1. There's some odd number.
Okay, I to the power of an odd number. Yeah.
That should be is a polynomial of integer coefficients of this n plus 1 over 2. I look up something like that. How do I do this? What?
You've got F-A-H-U?
F-A-U-H-L-B-A-U-R. I'll just guess how you spell it.
Okay. I don't know how you've managed to get this far as a mathematician and write your B's as 6. No, you can't have it anymore.
I just wanted you to guess what I'm writing. So let's think. Right. What's that?
That's a 5.
It's an S.
Oh.
Let's try and draw a 5. So 5S 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 B 6 B 6 B 6.
You're just writing the same thing. You know in your heart of hearts that you're writing the same thing, don't you?
I've got to think about it.
What do you mean you got to... What is there to think about? You're doing the same thing.
Are these with my twos and Z's?
Yeah, we'll put across. So who?
Z's.
Right, I suggest cross your fives,
No, but
cross your sixes.
have you seen my F's?
Oh no! Right, okay, so I'll cross it that way then. Right, 6K. I feel like that's a rune or something, isn't it? A weird astrology thing. I don't know.
Pisces.
Right, okay, well, because of your terrible handwriting, I'm not going to review your sequence.
No, that's a good thing.
Oh, fine. Right. A, no, I know it's a no. It's gone. No. 2717. 2717. Okay. Oh man, why does that keep happening?
Here too.
It does. I think that's a thing in Windows. Oh, it is.
Should I find out how to actually spell his name?
Nah. Right, so what was the one you showed me? Number of triangles and matchsticks. Okay. Aesthetics, I like the matchstick drawings.
Oh, so there's his actual name.
Foul Harbour. Okay. Well, I've just drawn that on top of my readings, so I'll put total down here. Okay. Aesthetics, I liked it, but matchsticks,
Doesn't have to be matched.
4 out of 5. Can you think of something that would improve it?
No. Kind of all the triangles are different colours.
Okay. Completeness, we haven't really looked at it. It's not finite. How many have they got? We've got 1,000 of them. Why are my emails picking up?
Oh, I was true.
Wait a minute. I just saw an amazing name. A032717. Wait, Genesis is one middle name. What's the A that you want to hide? Genesis, Anthrax, Padilla. Yeah, okay, right. Completeness, David.
You know, 3, 2,
What?
4.
3. What's the average of what you said? Explicability, very easy. 5 out of 5. Novelty is 0.
It may not be easy to explain how the sequence is what the comment says it is.
That's true. It's quite hard to prove.
Well, just keep it as 5 out of 9.
Okay. So everything's going to be over 45. So that's right, right?
Yeah, so 63 and 20. 83 out of 45. What is happening? Yeah, 83 out of 45. Should just say half.
Oh, but then I needed to multiply that by 4, didn't I? So 108. Well, because we've got 4 categories. So what did you say? 83. Yeah.
83 out of 160.
180.
Oh, a bit less than that.
Alright. Yeah. Well, I think that's fair. Right, that's enough of that. Lunchtime.
It is.
How do I stop that?